Alright, so today we are going to be going over composite area of polygons, and what it means for the area of a polygon to be composite. Alright, so remember back earlier we were talking about how the radius of a polygon was to the vortex of any of the vortex of the polygon, again dealing with regular polygons. And one way to think of this is to think of circumscribed by a circle, meaning you have the polygon being surrounded by that circle, whether it's a square, a triangle. Again, this is best done with regular, since irregular can go everywhere. Again, the center, since the only part of the polygon that's situated on the circle itself are the vertices or the corners, that means the radius of the circle is the distance from that center, which is the distance from the center to any point on the circle itself. Since the only points on the circle and the polygon are the vertices of the polygon, that means that the radius must go from the center to the vertices, or to the corners. Again, to the corners. So the radius of a circle is also the radius of the polygon, because the vertices are the only points on the circle. And the radius of a polygon is the distance from the center to any vertex of the polygon. So this is just another way of thinking about the radius. If you think of the radius, so think of it circumscribed, meaning surrounded by that circle. So if it's surrounded by the circle, the radius would be to any point on the edge of the circle. The only points on the edge of the circle and on the polygon is, of course, the edges or the corners. So that would be what the radius is. All right, and remember the apothem, that weird word, is straight from the center, straight down, perpendicular to any of the sides. So each side has its own apothem. And remember, this is going to be the height of the triangles we're using to solve for the polygon's radius, with the side being, the polygon area of the polygon, with the side being the base and the apothem being the height. Meaning all we have to do is multiply by the number of sides we have to get, because those are how many triangles we have. So because of that, for any regular polygon, the area is always going to be 1/2 the apothem. So that's 1/2 the apothem times the number of sides times the side length. So again, A is the apothem, N is the number of sides, and S is the side lengths. Alright, so that is what's important about the circumscribed of a polygon within a circle. So for a composite, that just means you have multiple shapes put together. So in this case, we have a triangle and a rectangle. So for the composites, you're doing just 3 things. 1, breaking it down into shapes you know the area of, or the formula for the area. So the area formula or equation. The second, you're solving for all of the area, or the individual areas. And third, because the sum of the whole is equal to the sum of its parts. Since we broke it down to the basic parts, we can then just add all the individuals. To give us the whole. Alright, so that's what we're going to be. We're going to be breaking it down into shapes we can use. Then we're going to be solving those shapes, and then we're just going to be adding them back together again. So for instance, if we look at this figure, we see we have what looks to be a rectangle with a triangle just sticking out the top. Alright, so we have straight across, we create a triangle, a right triangle at that, because that's a right triangle, and a rectangle. Now, we can use our knowledge of the areas of the formulas for the area of a rectangle, because we know that to be the length times the width. That's going to be the area of a rectangle. And in this case, I can just look and say, alright, so my width or my length is 5, whichever one, it doesn't matter. And my length is obviously 8 centimeters. Because of that, we know that, hey, the area must then be 5 times 8, which of course is 40. Alright, then we can come up. So I'm going to go ahead and write that over to the side because that's one of the areas. So I can go ahead and say the areas is equal to. So then for a triangle, we know that the area is equal to 1/2 the base times the height. Well, we already have the height right here, now we just need the base. So when we're looking for the base, we have to say, alright, so what on this figure can give us the length of that base? Well, we see that, hey, we're dealing with a triangle underneath. So we know this big area, or this big line, is going to be 8. So we know that 1 plus the base plus 2 has to be equal to 8, because we know that the sum of the whole is equal to the sum of its parts. So remember way back at the beginning of the year, we had the line segment addition postulate, which merely stated that the whole line is equal to the sum of the individual parts of it. So that means we can simplify this down to be 3 plus b is equal to 8. So again, we have to get b by itself. The opposite of addition is, of course, subtraction. So subtract 3 from both sides, giving us that the b is equal to 5. So that the base is equal to 5. Now that we know that, we can just come back in and put it into our formula. So that the area is 1/2 the base, which is 5, times the height, which again is 5. So we have 5 times 5. So that's 1/2 times 25. And of course, half of 25 is 12.5. So that's going to be the area of the triangle. So we can come over here and put that 12.5 over there. Now, as I said, we're dealing with a composite, so we're not dealing with the two individuals. We're dealing with the one whole. We broke it down into two individuals so that we could solve for each one, which gives us a part of that whole. So now we have to add those parts together to get the whole. So the total area is that triangle plus the rectangle. So again, we're going from one to the next. So that means we have 40, which is the area of the rectangle, plus 12.5, which is the area of the triangle. So 40 plus 12.5, that is 52.5. So that means our total area would be 52.5 centimeters squared. So once again, we're dealing with a composite. So hey, we can see, hey, that's a rectangle and another triangle. Again, being a right angle. Because again, we're dealing with a rectangle. So again, we can see quite easily length times width for the rectangle. Length being 8, width being 7. That's equal to the area, of course. So 8 times 7 is 56. So we can come over here and write 56 as our first area. Now we can come in for the triangle. So again, 1/2 base times height. Well, this time we're not given the base or the height. We have to figure it out. So we have our part of the whole. So it's always going to be the whole minus the extra. So in this case, the extra is 8 because we have that square. So we know that from here to here is 8. So that means that our let's call that the base, is 12 minus 8, which of course is 4. And we also know that the height over here, again, we are dealing with the whole minus the extra, which in this case is 4, so the whole is 7, and we're taking out that 4. So 7 minus 4 is of course 3. So we know that the area of the triangle is equal to 1/2, and that's a lot of, is equal to 1/2 the base times the height. So in this case, the base is 4, and the height is 3. So 1/2 of 4 is of course 2, so that would be 2 times 3, which is of course 6, equal to 6. So our 6 is our second one, so we can throw that up there with the other. So again, this being a composite, we have to add them together. Once we've broken them apart and solved, we add them to get the solution. So in this case, that means that the area will be 56 plus 6, which is of course 62. So that would be our area.